I'm really, really happy that there are so many people out there because I was sure that everybody's going to go home already because it's 6 p.m., right? So I guess after this gigantic amount of knowledge, you are very excited to listen to more stuff at 6 p.m., right? Last day of the conference. Good. So I'm really happy that you came to this talk called Continuous Deployment of Your Application. So before we go to the main topic, and we have a lot of stuff to discuss, a few words about myself. So my name is Marcin Grzejszczak. I know that it's absolutely impossible for you to pronounce it. I work for Pivotal, for the Spring Cloud team. And I am the lead of those 3 projects. Oh, you can't see what I'm pointing at. Never mind. I'm the lead of the Spring Cloud Sleuth, Contract, and Pipelines projects. My Twitter handle is @mgrzejszczak, but it's preferable to go to my blog, tomuchcoding.com, and find the handle over there. And you could have seen my, if you are already following me, that I have such a picture on Twitter. I've changed it to this. So this is me, 10 years later. So finally, that was a good change. Okay, who had to create a deployment pipeline from scratch? Raise your hand. Okay, we're friends here. Don't be shy. Don't be shy. You can raise your hand. Yeah, so that's kind of a problem, right? Now another question. Whose deployment pipeline looks like this? Right? If you're asking, don't raise your hand yet. The end-to-end tests are here. Now, 15 hours of them. So who has a similar deployment pipeline? Yeah, so there are some people. So whenever you go to a conference and you hear somebody say that you should do something or there is a special tool that solves all your problems, you should ask yourself a question: what problem are we actually trying to solve, right, with this tool, with this approach? Because if there's none, you shouldn't be actually fixing anything. So what we are trying to solve is the necessity to create a deployment pipeline from scratch for every single new project. And there's a bunch of reasons for that, and we're going to go through those reasons throughout this presentation. Now, this is the deployment pipeline. You can't see much. This is the deployment pipeline, let's say, created in Concourse, for Concourse. So Concourse is the CI tool and CD tool that allows you to build and deploy your applications. Those green boxes, don't worry, we're going to zoom in to them later. Those green boxes are actually tasks, jobs pretty much, that should be executed. So who has used Concourse? Okay, there are some people, good. Now, Jenkins, who's using Jenkins? Oh yeah, that was expected. Who has ever seen Jenkins Job DSL? I am really happy to see that many hands. So, for those who don't know, Jenkins Job DSL is a library that allows you to code your jobs using a DSL. It's not dynamic. It's pretty much, let's say, properly written, so it's statically typed with some dynamic pieces and wherever it's necessary. This is, as far as I remember, it's called the delivery pipeline view. So instead of having this endless deployment pipeline that destroys your browser every 10 minutes, you can have a nice view with stages and jobs. Now, who uses the Jenkinsfile approach? Okay, a few people. And the last question, who uses Blue Ocean? Okay, so I can see the resemblance of that. All the people who raise their hands with Jenkinsfile use Blue Ocean. So even though it's called Blue Ocean, you can see green since the build has passed. You have the same deployment pipeline going from left to right. And Jenkinsfile, for those who don't know, it's the new approach of creating pipelines for Jenkins that has absolutely no support for IDE, and you have to read the docs on how to write it. They say it's groovy. You can't write groovy in this file because it's going to fail, saying you can't write it here, you can write it somewhere else. Bizarre stuff, at least for me. Okay, so what are we going to work with? We're going to have a certain set of apps. So there's going to be GitHub that emits hooks like events, HTTP calls. And there's going to be an app called GitHub Webhook that, believe it or not, registers to webhook from GitHub. And it's going to send a message via MQP to GitHub Analytics. And we're going to be focusing on GitHub Analytics quite a lot today. So now, before we go to the crux of the matter, the question is, why do we even deploy software? Because this is kind of funny that developers forget about this like small thing, because often developers want to play around, like they go to a conference and they heard that now they have to use Mongo because they have to do it. So we need Mongo right now because at the conference they told us use Mongo. Or we need to go to microservices. Not right now. Let's leave everything, go to microservices. But believe it or not, but we're paid when we deliver business value. I know that it's not cool to say that, I know, but that's the reality. So the feature is done when it's deployed to production. Your stage doesn't matter, your test doesn't matter, your pre-prod doesn't even matter, right? Only when you have gone to production, you earn money. And now, obviously, not a single person over here deploys software to production like every 6 months. Obviously, you do it like what, every day, every hour, right? Something like this. So we would like to maintain this pace of deploying frequently for a reason, because we can get faster feedback. Technical feedback, meaning we push not a lot of code, like small changes, fewer bugs. It's like statistics, right? Our technical, let's say, decisions can be tested very fast, and if something goes wrong, we can easily roll it back. And from the business perspective, so if the business has some ideas, it's better to see it faster than they make or actually don't make sense, and react accordingly rather than wait year and a half because there's no chance that we're going to do it like in the time defined. So there's going to be a delay costs money, etc., etc. So we want to do it as often as possible. And we would like to also fail as fast as possible. So if we have, some null pointers thrown in our code, something's not working, we'd like to, fail on our laptops without even pushing the code. And we're going to look at certain techniques that can allow us to fail in terms of, faulty integrations. Now, deployments should take place in a standardized, automated fashion. I know that all developers, love to write their own stuff. Like, I know that another team runs their software in that way. We're going to do exactly the opposite because we're not going to copy the concept from them, right? And then you have 25 ways of running an app, right? And you have to support 25 different scripts. So we don't want this. Now, my favorite. Raise your hand if your deployment pipeline tests if you can roll back. 3, 4, good. 5 people, nice. So yeah, that's kind of problematic. So it would be kind of good to see if we can actually roll back. It's not like something bizarre, right, that you would like to roll back. So most likely the rest is just, pushing the code and praying like, I pray that the database upgrade's going to pass. If that passes, well, it's good, right? But yeah, so let's find out how we can fix this. If we can roll back, it means that actually we can do zero downtime deployment because we can have 2 apps running at the same time, all the new version, right? So this is what we want to achieve, and let's focus on failing fast. So I zoom in to our pipeline. We have build and upload and build API compatibility check, 2 steps. So we have a problem called slow feedback. By the way, in this presentation, you're going to see a couple of Captain Obvious solutions to the problems. Let's start with the problem. So slow feedback. We don't want to wait until the end of the deployment pipeline to see that something's not working fine, especially, often we have those end-to-end tests that take 58 hours to run. And of course, you have to, rerun them 3 times, and, and then they're going to pass, right? So in one of the companies I worked for, we've managed to even split end-to-end tests into separate jobs in Jenkins, so we can rerun only a job, right? Not the whole suite. Of course, it's a terrible thing to do because it only proves that we didn't solve the original problem. But yeah, so what we would like to achieve is to fail as fast as possible, like shift left in the pipeline. So we want to fail fast even on our laptops, especially if integration is faulty and if our API is backward incompatible. Who checks if their API is backward compatible or incompatible? Okay, nobody. That's interesting. So, problem was slow feedback. Solution is fail fast, right? So we have unit integration tests. Of course, you are doing TDD always, right? You haven't written a single line of production code without a test, right? You don't have to raise your hand because I know that you do it. And you have the proper testing pyramid, a lot of units, like plenty of unit tests. in some integration tests, almost no end-to-end tests, right? Okay. So you have unit integration tests, that's pretty obvious. And we can actually use contract testing, one of the frameworks that implements that approach is Spring Cloud Contract, to test the faulty integration. So now I'm giving talks about Spring Cloud Contract, and now I'm going to show Spring Cloud Contract in like 5 slides or so bear with me. I have a lot of pictures and arrows, so that should work. So we have a producer and a consumer. Right? A producer is a service that produces an API, like has a controller, or sends a message. And a consumer is the one that sends a request or listens for a message. So a producer defines a contract, where a contract is an agreement on how the API should look like, or the message should look like. And now, from the contract, tests are generated to see if the producer is not lying. So if the producer says, I have such an endpoint, or I send such a message, if it's not tested that it's the case, the contract is useless. So we generate tests to see if that's true. And we also generate stubs. Right? From the contract, we generate tests, and we generate stubs. Now, all stubs reside in Nexus, Artifactory, Git, some location. So they can be reused by consumers without running the producer. So that's the very essence of a stub. Right? Why? Because we would like to fail at build time if integration is faulty. And we're going to see a demo on the slides, obviously, how it could look like. So right now, we're going to break the consumer. And we'll see if our pipeline can check it. So let us assume that we have, again, the same flow. So this is the producer of the message, right? Of the AMQP message. So this is a contract. Hopefully you can see it. So what we have here is a groovy definition of a contract. We have some labels, an input part. We're going to go to that later. Most important thing is to the bottom, you can see, or not. You cannot see it, so just read it. Then we have the body section. And like in the output message section, we have sent 2 body and headers, meaning the producer of the message says, I vouch that I can send a message to a destination called messages with this body and these headers. Important thing is to see that the body contains fields username and repository, right? So in the payload of the message, we're going to have username and repository. So what's going to happen is, from the contract, it's going to be read by a Maven or Gradle plugin. Tests and a stub will be generated. So this is the generated test. A human didn't write it. It's generated. And now, in the contract, we had triggered by on the input side. Because if you have HTTP communication, it's blocking. Like, I send you a request, I expect a response. With messaging, that's not the case. Suddenly, you're going to have a message on some queue topic or whatever. So we need to, on the producer side, somehow trigger the message to verify if, start this process at the end of which the message will be sent. So when we said trigger by create issue v2, we actually call a method, create issue v2, that should generate the message. Then we said output message should be sent to messages. So we verify, try to retrieve a message from a queue called messages, right? If we manage to get the message from that queue, you said that there are going to be 2 headers. So we will assert that. If you're missing those headers, your build, Mr. Producer, will be broken. And then you mentioned the body, right? It should contain username and repository. So we don't trust you. We will verify that, right? So we have generated tests. So now we have the consumer, so GitHub Analytics, that listens to the messages coming from the AMQP queue. So we have a pojo that describes the payload of the message, username and repository. And now we have the tests of GitHub Analytics, right? So the consumer. We run the tests, and Spring Cloud Contract has a component called stub runner. Believe it or not, but it's running stubs. How is it doing it? So it's going to Nexus saying, please fetch the stubs of GitHub webhook. OK, fair enough. There you go. These are the stubs. And then we're running the test method, and we can already leverage the stub of the producer. So we have the test, and we have auto-configure stub runner that did what I've just shown you. So we say, fetch stubs from Nexus. Now, The model on the GitHub Analytics side is that it's analyzing number of GitHub issues. So the initial count of issues was 0. Then a message has to be triggered, and we should have 1 issue stored. So over here, remember in the contract, we had something like a label. Since we need to trigger a message, we will use the label from the messaging contract to actually trigger the message from the stub. So our test doesn't even know that a message comes from the stub, and we should have 1 issue stored at the end of the day. Great. So now, somebody's insane and wants to break the contract. So let's go to the producer. And somebody says, username and repository is too long. Let me shorten it to user and repo. Is that a breaking change? Yes, it is, because we're modifying the fields. So, GitHub Webhook decided that YOLO, let's push the stubs and all the code, like the fat jar, the stubs to Nexus, and let's go to production. So new stubs with backward incompatible changes got uploaded. So if we check out the consumer, if we try to build it, it will break. And why is it so? We fetched the broken stubs from Nexus. We had the initial count of 0 issues. We trigger the new stubbed message, and we're going to have a violation saying, hey, repository and username cannot be nil, and they are nil, right? So in that case, we didn't have to even start the producer code. We can actually run this code like the build on our laptops, and it will break, because the latest stubs are not compatible. So that's pretty cool, because all the consumers will be immediately broken once somebody breaks the compatibility. But that's kind of sad, because the producer could have gone to production. So all the apps in production are broken, which is really, really sad. And we don't want this to happen. So how can we stop the producer from doing this hideous thing? So what we're going to do is, let's take another look let's take a look at another contract. Let's go to HTTP. We have GitHub Analytics in version V1 that has an endpoint, like a controller, with URL issues that accepts the delete method, right? And in the contracts, we have defined exactly this situation. So we're going to see that contract in a second. So the generated tests got, created and executed. So this is the contract, very simple. Method delete to URL issues should return status to 100. So this is the test, saying if you send the delete to issues, we expect status code to be to 100. Great. So we've gone to production with GitHub Analytics V1. And again, we have somebody who's insane and decided to remove the endpoint, because why not, right? So the endpoint got removed, the contracts got removed, so there are no auto-generated tests, right? Sad situation. And if you don't believe me, I put a git diff on the slide to show you that I really deleted that, right? No delete mapping, no contract. So what we can do actually is to verify the following. Is our V2 version of the app compatible with V1 contracts of our app? Because we know that we've gone to production, so V1 is currently on production. So we want to be sure that our current code is compatible with the API that is currently on production. Because if it's not, if that thing went to production and we had round robin on production, every second request to the endpoint would result in 404. So that kind of sucks. We don't want this to happen. So this will fail. Why? Because from the contracts from V1, we generate tests. So there's going to be a big boom, since the generated tests will fail, right? And this is what happens at the second step of our pipeline. So at the first step, we say, we've built V2. But on the second step, we say, current implementation V2 is not compatible with contracts of V1. Because this test is generated from old contracts, but there is no such endpoint. So this test will break. Yeah, because I deleted the code. Cool, so this is how you can extremely fast fail, and you can actually verify this even without pushing the code. Now, standardization automation, and rolling back. So we have 4 steps: test deploy, test smoke, test rollback deploy, test rollback smoke. If you standardize, believe it or not, but you're lowering support costs in your company because you do stuff in the same way. In one of the companies I work for, we had, I think, 5 different ways of running the app. So we had run sh, start sh, Java jar, no hub, manually executed. We had health endpoints where health, ping, actuator health, I guess. So yeah, and you have to know about this to properly support it. So that's really bad. And if you do stuff in a similar way, you can rotate people much easier because everything is done in the same way. So the solution to this is usage of platform and certain tooling to standardize, for example, schema versioning. So if you use a platform, you can standardize the way you deploy and monitor your software. And Spring Cloud Pipelines works out of the box with Cloud Foundry and Kubernetes, and also PCF Dev and Minikube. PaaS is obviously a very great idea to abstract the way you govern your app from the underlying infrastructure. So regardless of whether you're running your app on a laptop, Amazon, Google, Azure, it doesn't really matter. You do stuff in a similar way. And if you are, right now versioning your schema not in an automated way, you should definitely check those tools like Flyware or Liquibase that allow you to do so. So in an automated fashion, you can upgrade the schema, and when your app starts, it can upgrade the schema of the database that it's connecting to. And we're going to be playing around with Flyway today. So let's focus on test deploy and test smoke. So let us imagine that we're in a Cloud Foundry space or a Kubernetes namespace. So what we're going to do right now is, let's say we have some services, RabbitMQ, MySQL, and Eureka, Spring Cloud services. So before we deploy our app, so what we would like to do in this test environment is test our app in isolation. We don't want to yet do any end-to-end tests. We'd like to test the app in isolation. What does it mean? I mean, our app has to interact with other apps. Some HTTP calls have to be done, or messages have to be sent. So I've shown you StubRunner, so you've seen it in the code, how to configure StubRunner. But StubRunner can come as a standalone app. What is more, StubRunner can fetch your stubs. That's what it's for. But it can connect to a real broker and a real discovery service, which means that your stubs, like fake HTTP servers bound to real ports, can register themselves in Eureka or whatever else, and the stubbed message, as if a producer sent it, can be sent to a real Rabbit. So then we deploy GitHub Analytics. GitHub Analytics connects to MySQL and upgrades the schema, and then for the tests, it can talk to the Eureka, like Spring Cloud services, or the Rabbit, as if the producer was there, but it's really not, because it's a stub. So our app is completely surrounded with stubs, and our app doesn't even know about this. So the problem we're trying to solve is rolling back the database. We should verify if we can roll back in any way. And rolling back database changes is extremely difficult, because if you deploy every 6 months, you have billions of trillions of lines of code and hundreds of thousands of changes of your schema. At least one of them has to be a deletion of a column, obviously. So how can you roll it back? It's kind of problematic. And of course, you can say, we use Liquibase, so we can enforce rollback scripts, right? And if you don't put it, we're going to break the build. Sure, but I can put in the rollback script select 1 equals 1. And now what? I pass the requirement, the build goes through. But actually, I don't think select 1 equals 1 will allow to roll back the deletion of a column. So that can be kind of problematic. And actually, I'm not joking, I've seen it. It's a bad thing to do. And there are tools that do not allow you to roll back at all. So let's go to this second part of the test phase. Test rollback deploy, test rollback smoke. So rolling back the database is problematic, right? So let's not do it. Captain Obvious solution. Whatever's problematic, don't do it. So what we can do is try to verify that we are always doing backward compatible changes, or we're performing, now it's a tongue twister, backward incompatible changes in a backward compatible way. And I wrote a blog post about it. It's called Zero Downtime Deployment with a Database. So, for example, if you're renaming, it's on the Spring.io blog. If you're renaming a column, you can do it in 4 deployments, as far as I remember. But actually, since it's very problematic to support this, you can think that maybe the column's name is really the best ever, right? If I don't have to support 4 deployments to actually rename it, yeah. So what we want to achieve is we want to roll back the app only. We don't want to touch the database. That way, we have to ensure that app and DB changes are compatible with each other, because that way we can ensure that the old and new versions of the app can work together at the same time against the same database. So let's check out the demo. We have GitHub Analytics in V1, and inside the code we are, let's say we're using Hibernate, whatever, and we expect from the code a column to be called repository, to store some data there, right? So in the schema in V1, we have a column called repository. Seems pretty obvious. So we're using Flyway, and Flyway integrates perfectly with Spring Boot. So we have source main resources, DB migration V1 in its SQL, where we define the table for issues. There should be an ID, username, and repository, right? So when our app starts, it connects to the database, and such a schema will be created. We go through the whole flow. We went to production. We have V1 on production. So this is our schema. ID, repository, username. Now, again, YOLO, let's rename the column from repository to repo. Why not? So in the code, we do refactor, rename, and the schema gets renamed. And as a hint, we name the Flyway script v2 breaking change. And in the comment, we write, it's a backward incompatible breaking change. And we change the column from repository to repo. So this is the new schema, right? Awesome. So what do we want to check right now? It would be kind of cool to see if our V1 version of the app, the one from production, can communicate with the V2 of the database, right? Because that would be the case if we had gone to production, because V2 would upgrade the schema to V2, but there would be the V1 app still there trying to insert data to the new database, like to the upgraded schema. So as you can imagine, it's not going to end well. We start over here, test deploy, the second run, right? New application V2 bumps the schema to V2, and we run some tests, some smoke tests. So we write smoke because if you have like 100 features of your service and 10 of them are really important, so smoke tests should check those 10 features, not 100, because you have already tested them in a unit and integration way. I know that I don't have to tell it to you because you don't have the inverse pyramid where you have like billions of end-to-end tests and zillions of UI tests. But yeah, just saying. And now we continue. And over here, what we do is we kill the V2 app, the jar, and we deploy V1 of the jar, and we connect it to the V2 of the schema, right, of the database. And then we try to run the old tests of V1, and that's not going to end well. Right? Why? Because if you check out Logregator in Cloud Foundry, for instance, you're going to see the beautiful my syntax error exception unknown column repository. So we have just saved, by just doing this, so we've managed to test the API compatibility, the database compatibility. I think we saved quite a lot of money and support hell, because, for example, you would have done this at night, obviously, right? And you have to wake up because there was a breaking change. No way, you're not going to go through the pipeline. Okay, time for stage. So we have stage deploy and stage end-to-end. So time for controversy, because like I said, we're friends here. So I'm going to be honest. I have a problem. I have a problem with end-to-end tests. For me, it's like pure hypocrisy, because in the Spring Cloud team, I write almost only end-to-end tests for our stuff. So that's terrible. But it's a special situation, right? So why I don't like end-to-end tests? Because they are slow and tend to be very brittle. I know that you all love checking why you have 500 as a request. And now you have to see which one of those 58 services deployed out there through the null pointer, right? And I've met in one of the companies a QA department that told me, when I asked them why do you write an end-to-end test or UI test for a feature that gives us $1 per year? Why do you write a test for that? And I heard, because we are paid to do so. I'm not joking. Now, who has a special team at their company that obfuscates data from production? Okay, don't be shy, raise your hand. Okay, there are a couple of people. So the rest don't even bother with, having production-like data on stage. So yeah, there are teams that have to do it. So you cannot have production data on stage or pre-prod or whatever due to security reasons. So one way is to actually generate data from the schema. But if you think that, oh yes, this is the perfect solution, no, it's not. No, it's not, because often this data is not logically correct. It's technically correct, but for example, you have to generate a client ID, and it's a special, not like combination of numbers and, for example, digits that all together have to be logically correct. So, sorry. And typically you have a separate team that wants to quit the moment they got the job, that only supports this like day after day after day. Another question, end-to-end test environment setup. There are companies where there's one environment that has been set up by somebody 25 years ago, and it really works. Nobody wants to touch it with a stick because it kind of works. And it's shared, so and it takes obviously 10 hours to run the tests. So there are 10 teams. Everybody runs the tests like for 10 hours. So you have to queue to wait for your turn, which takes 100 hours. But of course, it never runs the first time, so you have to rerun. So you have to wait 500 hours to pass the end-to-end tests. Yeah, so one environment shared between all applications. But maybe you have a lot of money. Then you have one environment per application. Fair enough. So another question. Should the surrounding apps be, the surrounding apps, should they be deployed in production versions, development versions, or both? Do you test your app against other snapshots or other production versions? That's a good question. Maybe both. So from 500 hours, we went to 1,000 hours because you have to do it twice. That kind of sucks. So, problem was end-to-end tests. So the solution, maybe let's not do them. It's not that easy and it's not that obvious, but let's try to have this sort of a thesis. Why? Why could you consider not doing end-to-end tests? Because regardless of the time you spend on QA or UATs, you can still have bugs on production. I remember we had, QA department was clicking around like crazy on stage, and then on production after deployment, the app didn't start. We didn't have a platform back then, so it turned out that we needed a file on the file system, and somebody deleted it accidentally. Oh, come on, it happens, right? Everybody, remember GitLab? It happened to them as well, like 300 gigs of data lost. So, assuming that you embrace failure, so it's not going to really always work. Let's embrace that we're going to have problems, but small ones. And we introduce monitoring of our key performance indicators. So who actually has monitoring of the business aspects of their apps? That's depressing. So the rest of you checks like health, right, the memory, awesome. Is there an option that you deployed your app, it's pure, like healthy, it was never healthier. It's actually the best, it's having the best time of its life. And the whole business is gone. It's like, we are no money. So what you should immediately do is to use, for example, Micrometer to verify that your key performance indicator, the business ones, are working fine. So for example, in the case of GitHub Analytics, the number of issues stored at the moment. If, for example, for some reason we go below 100, something is seriously wrong, right? And we have alerting. So the moment we go below the threshold, you should have like PagerDuty or any other mean of communicating to us that get up, situation is bad. We should have it. And trust me, the moment you do, not siloed teams, but self-contained teams that are responsible for everything, if a developer, instead of taking the shovel after writing the software and putting over the wall to the QAs, and then the QAs to support, if you change that approach to dear developers, you write it, you support it, and you wake up at night, trust me, they will test the thing like crazy. like never before, because we like to sleep, right? And if you ensure that you can roll back on production, and obviously the whole thing of not doing end-to-end tests makes sense from the point of view of the business. So we talk to the business, and it makes sense from the business perspective. You could theoretically, maybe, stop doing end-to-end tests. But since it's pretty controversial, the step is still there, it's manual. Why is it manual? Because you have to wait for your turn, and you have to purge stale data, do some manual stuff, deployment of some other things. So both of these steps are manual. Now, production, our favorite place, apart from start of Spring.io, right? So, prod deploy, prod complete, prod rollback. Who loves doing deployment to production at night? Don't be shy. Yay, I knew it. There's always this one person. Actually, I know that we like parties, right? So there's a deployment to production party. We've been coding for 28 months. Finally, after almost going bankrupt, we have a party, right? We will go to production. Of course, we have to spend 2 months on fixing bugs in production, but yay. No, we don't want to do it. So we would like to achieve a situation where that we even forget that there's a deployment. It just happens out of the box. You merge to master, there's deployment to production. You would like to do A/B and zero downtime deployment to be less scared. Because we want to be sure that if something goes wrong, we can easily roll back. So a solution to this can be the platform and Spring Cloud pipelines. So assuming that we have the monitoring of KPIs, we have the alerts, we went for the pipeline, so it's been tested, we can roll back. Platform can take care of zero downtime deployment. And now, Spring Cloud pipelines, what do we have there? So we have prod deploy step, so it deploys the production app, the version that we have tested for the deployment pipeline next to the currently working app on production, right? So if you have something there, we're going to deploy it next to it. And we tag the repo with prod/version. Why? Because we need to know it for the backward compatibility checks, right? If, let's say we are running the two apps for some time, the KPIs are good, everything seems fine, we can gradually increase the number of instances, the canary release and stuff like that. Once we're happy, we can do prod complete, which means we're done, let's kill the old instance. But if something goes wrong, we can press prod rollback, and we're rolling back as if we have never done a deployment. So now time for the demo. So we have a production space in Cloud Foundry, we have the services, we have GitHub Analytics in V1. We bind to the services, we upgrade the schema to V1, and we bind the route to GitHub Analytics, whatever, like CFApps.io. So this is our first deployment. We have, let's say, the view of the of our deployment. We have the V1 running there and bound to the route, right? Cool. So now V2. Oh, before we do that, we have to rename the app from GitHub Analytics to GitHub Analytics Venerable. It's actually a word. We do it, we rename it, and now we deploy the V2 with the name GitHub Analytics, right? So the old one is with the suffix venerable, the new one is like without the suffix. We bind to the services, we upgrade the schema, and only after all the checks are passing will we bind the route, the same route. Which means that we have old instance, new instance, and the same host name, meaning the platform will do the round robin, like the load balancing. Comes out of the box. So this is the whole deployment pipeline, and now let's go to some technicalities. What is Spring Cloud Pipelines then? So it's a GitHub project that contains an opinionated template of a deployment pipeline. It's based on good practices from different projects. It's not that somebody woke up in the morning and said, this is how you should deploy. Oh, actually took a picture of me doing this. It's going to be so bizarre. And we believe in the infrastructure as code approach. So who loves clicking jobs in Jenkins? Nobody? That's good. So we want to code everything. We want to code the pipeline, the setup of, Concourse is actually comes out of the box. So we just, the Docker Compose app or whatever, it's there. But with Jenkins, you have to know a lot of dark magic to automate that. Because if something goes wrong, we want to recover in no time, and you should automate the server setup too. Who writes tests for their pipelines? One person. Okay. So we also write tests for the pipelines. And we support following automation servers out of the box, Concourse, Jenkins using Jenkins Job DSL plugin and Jenkins using Jenkinsfile with Blue Ocean. But logic of all the steps that you've seen is done via bash, which means you can convert the internal to suit your needs in whatever way you please, and you can use whatever automation server you want, because it's enough to set the environment variables and run the bash script. That's it. We support Maven and Gradle out of the box, so your app doesn't have to tell us whether it's using Maven or Gradle. The pipeline will know it. And I am a test freak, so I wrote over 150 BATS tests. BATS is a framework for testing bash. So if you're having some bash scripts, you should test them with, for example, this framework. So how does it really work? So we have Jenkins or Concourse, whatever, and we have the Spring Cloud Pipelines GitHub project. We provide, out of the box, the definition of a pipeline in Concourse and the definition of a seed job. A seed job in Jenkins is a job that generates other jobs. So it's a seed job. So once you run those, providing some parameters, we generate the pipelines, right? And when you run the pipeline with the environment variables that are required, like where is your production space in Cloud Foundry, et cetera, some credentials have to be set, a bash script is executed and it's sourcing different bizarre stuff. And the bash scripts also come from Spring Cloud Pipelines. So when you run the script, like when you run the step in your CI system, it's going to execute the bash scripts from the cloned Spring Cloud Pipelines repository. So how do the scripts work? Time for some bash magic. So this is the Spring Cloud Pipelines project, and we have the common folder. Under the common folder, we have quite a few bash scripts. Each of them pretty much represents a step inside the pipeline. But there's one special, you're going to see that in a second. There's one special file called pipeline.sh. So we have the build and upload sh script. So you have seen that there's a build and upload step. So what it does, it's essentially calling the build function, and that's it. But where is the build function defined? So we have some sourcing done. So we are sourcing the pipeline.sh. Now, what do we have here? We have the function that exits with 1. That's kind of sad. So for those who don't know, if you exit 1, that's like an error, pretty much, right? So it doesn't really look good, right? So this is a poor man's version of an interface in bash. So it's a function that echoes and does nothing and breaks your build. So what you have to do, you have to override it to make something happen. So for instance, in pipeline-maven, so when we check out that you have Maven, we did define the function build. The same for Gradle. The same for if you used SBT or something else, right? So you have to define certain functions that, tell us how to build your stuff. Now, this is just building. What about deploying? So there are different passes, right? Platform as a service. So we have support for CF and case. So there is if you set an environment variable pass type to CF, we're going to source the pipeline-cf sh, right? And here, for example, there's a function called complete switchover, and there's exactly the same function for K8s, for Kubernetes. So if you use some other platform, you could do exactly the same thing, right? So sourcing functions, interfaces in bash. So will my applications work out of the box? No, but you have to follow certain conventions. So there are different conventions for Cloud Foundry, Kubernetes, Maven, and Gradle. Let's take a look at certain conventions for Maven. You have to use Maven wrapper. Settings XML has to be parameterized because we will inject the credentials. We deploy via clean deploy, so if you have special tasks, okay, it's your problem. You have to bind it somehow that it works with clean deploy. Of course, you can override it, but these are the conventions we take out of the box. We require certain properties to be there, like with predefined names. Also, the pipeline will inject certain properties for you that you can reuse. When we execute the step for API compatibility check, we actually run your build with a profile called API compatibility, right? So it's up to you to decide what that means, and we show some certain samples what it means for us. The same for smoke. So smoke test is actually running the build with smoke profile, and end-to-end is running the build with A2E profile. Very similar thing is for Gradle, where you have tasks, and also the properties are required, etc. So this is a convention-based approach. So how can you customize it? You can go to the releases and download the source code, or you can, fork the code, or you can, since I am an automation freak, you can use this curl to, download the zip, unzip, and there is the command called Gradle W customize, where there is a CLI asking you questions like, do you want to use Jenkins or Concourse? Do you want to use CF or Case? And you pick, and we delete all the unnecessary code for you. And now, if you decided to use Sprinkle pipelines, please go to issue 55 and tell me what you actually customized, because I'm going to put it in the code for other people to reuse. So yeah, you don't have to do it the next time. Okay, summary. Oh, we're going to have some time for questions. Cool. So doing continuous delivery and deployment allows you to do continuously deliver business value, and it gives us money. And Sprinkle Pipelines gives you tooling to do it out of the box, and there are different tests. Unit integration, obviously, contract testing, rollback testing. And this is crucial. You don't have to take everything from the very beginning. You can gradually migrate to use the project. You don't have to apply all the changes, and Cora Iberclyde has created, as part of the documentation, a step-by-step, there's a step-by-step Cloud Foundry migration guide, where she shows an app that is, let's say, sort of a legacy app, and she migrates it gradually to work with Sprinkle pipelines. And Sprinkle pipelines gives you hooks in Bash to override your stuff in the way you please. And since it's convention-based, it's working with tasks and profiles, you can define what those mean in your company. And if you're using a PaaS, you can easily do AB and zero downtime deployment. So these are the links to certain apps that we have already written for Sprinkle pipelines, the 4 first apps that follow the conventions, that they do all the contract tests, and they go through the pipeline every 3 hours or something like this in our CI systems. You can check out the documentation Sprinkle pipelines and the step-by-step guide. And also, if you want to play around with Cloud Foundry, you can go to runpivotal.io and play around with it. Okay, so we have time for questions. Any questions? Anybody? I can see you really good. So, I can't see any questions. If you have raising your hand, I can see you, just shout. No? Okay. So if you don't have any questions, thank you very much. You can come here and you can chat, or you can chat to me over the beer or something. Thank you.